I've been a professional software developer for well over 5 years now. Worked on a ton of different projects, learned a bunch of languages, tools, frameworks, and technologies. Today I'm going to be sharing 3 things that I wish I knew before I started software development. They're going to help you guys in your career, help you guys get better at writing code, and help you guys build the stuff that you actually want to build. Welcome back to Tommy Codes. My name is Tommy. Let's jump right into it. First up on the list, your IDE is your home. Get comfortable in it. As a developer, the actual software you use to write software is called an integrated development environment. For most of you, that's either going to be VS Code, which I don't endorse, or JetBrains, which I am a big fan of and have made some videos on. If you're curious, check them out up here. But regardless of which one you choose, it really pays to get good at the actual software. Like the act of using the IDE is a skill that you need to improve on. You need to take the time to learn all the shortcuts. You need to find the right plugins that make you more efficient. And it also even pays to understand a little bit about how these work at a lower level. It's going to make you understand the language you're working with better. And it's also going to really help when errors arise and your IDE is crashing or it's being slow or any other nonsense pops up. You're going to have to fix it yourself. And even with AI, which of course is changing the way that developers write code, it's making a lot of people more efficient. A lot of developers would frankly benefit more from just getting good with their IDE than spending time using AI to augment their workflows. It's not that hard to learn the shortcuts. It's not that hard, honestly, to get good at your IDE if you are willing and able. Once you do, that knowledge is with you forever, and that's literally going to improve your efficiency for your entire life. It's obvious when someone is good with their IDE. Software development is often a game of just not wasting time, not getting stuck managing your dependencies, not getting stuck installing a new project. Being really good at your IDE is going to enable all of this. And not to mention, of course, AI is very helpful, but the debugger in your IDE is one of the most powerful tools for getting anything done, especially if it's a complicated code base, especially if there's no documentation. If you're good with your IDE, none of this even matters. You can jump into a new piece of code, hop in the debugger, start poking around and start really getting a sense of what's going on, even if there's zero documentation and even if there's zero AI tools available. It's just such a high return play to get good at this stuff, and the effort is really not that high, guys. It's not that hard to read some documentation. It's not that hard to watch some videos on YouTube and just practice. Just practice, really. You will thank me, and everyone around you will notice as well. Have you ever been in a meeting with a senior engineer and he's just effortlessly flying around the code, making changes, not even really stopping to do anything, just complete flow state with the software? That's where you want to be. That's going to really pay dividends. The next thing I wish I knew before I started software engineering is learn how to deploy software, learn how the cloud works at a high level. If you're a software engineer at a larger company, you might not have to think about this stuff at all. You might hit merge on a PR and forget about your change. You don't have to worry about how it's going to get to production. You don't have to worry about the automated tests that are running. You don't have to worry about any of this stuff. You probably have a support team of cloud engineers or DevOps engineers whose entire job it is to solve this problem for you of how does code go from your laptop into production. But if you really want to be effective, especially on your own, this stuff becomes really important. First of all, if you run into any issues with the cloud, if you don't know what's going on with the CI, or if you're trying to deploy a new piece of software and you don't know anything, then you have to go to a cloud engineer or a DevOps engineer and more or less get on your knees and beg them for their time. Maybe you have a good relationship with them, maybe they're really awesome and this works great, but that's not a guarantee. And maybe they're out sick, or maybe they're just not very good, or you don't like them for whatever reason. And when that happens, there's a lot of friction now in getting anything done because you're relying on these other people to solve some of your problems for you. And in some cases, they might not care about your problems, especially if you're trying to bring about a new initiative at your company or do something a little more ambitious. You have to convince them to help you. And you might not be that good at it. They might not care. They might not be willing to put in some extra work and help you out. So if you're able to do a lot of this stuff on your own, if you understand that story of how software goes from laptop into production, then you can make a lot of progress on things that would otherwise require their permission and guidance. And not only that, but when I originally got into software, I guess what really drew me to it was the ability to actually build something end to end, create something out of nothing. And if you want to be able to do that on your own without the support staff of cloud engineers and DevOps engineers, then the cloud becomes really important. And not only that, but most pieces of software, you actually do at some point have to think about what type of machines are these running on? What does the architecture look like? What cloud services do I need to make this happen? And specifically, what's going on with those services? How do I scale them up? How do I monitor them? How do I deal with logging? And the code you're writing as well, if you become more of a senior engineer, you have to start thinking about how are we going to quality control this code? How are we going to run automated tests? All of this stuff requires knowledge of the cloud, of DevOps, of a lot of this stuff that frankly a lot of engineers look down upon. They kind of don't think it's very glamorous. They don't think it's important. It's kind of beneath them for whatever reason. But this stuff just enables you to get so much done. Knowing this stuff will make you a lot more effective. And again, it's not glamorous. It's not that difficult if you're willing to put in the time, but the payoff is crazy. You'll be so much more effective. They'll look at you as a senior engineer just because you know the cloud stuff and they don't, because you're gonna have a much more holistic picture of how software actually gets deployed. And you're just never gonna get blocked. Being blocked is often a choice. The next thing I wish I knew before I started software engineering is don't be afraid to look at code that you don't own. And I'm gonna tell you guys a story to illustrate this point. I was working as a software engineer at a high frequency trading firm. The code I was writing was executing trades in the US options market. And a lot of our success depended upon us being fast, us being first in the orders we were placing. The software in many cases was not fast enough. We had to offload a lot of the logic onto hardware, onto FPGAs. Because of this, there was an API layer between the software that I was writing and the hardware on the FPGAs. They had to communicate somehow. Any new feature that interfaced with the FPGA required understanding how the FPGA worked, at least at a high level. At this company, we had a full FPGA team who were very helpful. And I was working on a new feature, so I went to the FPGA engineer and I basically did an interview. We sat down for an hour. I asked him a bunch of questions, and then I went back to my desk to write some code, only to realize, oh, I still don't understand what's going on. I need to ask him more questions. So what did I do? I carefully crafted a list of 5 more questions on Slack. I went into a lot of detail. Hey, how does this work? What happens when case X happens? What happens when case Y happens? This took me 30 minutes to even write the questions. I wanted to be respectful of his time, so I wanted to make sure I did my research. And then I sent off the questions, and then I waited, and I waited, and I waited. And then finally, I get a response back. He answers all my questions. Great, now I can finally get started coding. Then I go back to my desk to write the code, and I realize I still have more questions. I still need to ask this guy more questions. So I went and started to cook up more of the questions on Slack. But then I realized this is really, really slow. And if we're going to actually get this done, I don't want to be blocked by this person. And I also don't want to waste his time anymore because he has better things to do than just answering basic questions. So what I do, I actually went and downloaded the FPGA code, which anybody could do at the company. And I was able to find the area of the FPGA code that was relevant for the feature that I was working on. And while I am not an expert in that area, and while I wasn't understanding 100% of what was going on there, it was definitely very helpful and was able to answer a lot of my own questions. Once I did this, I was able to start writing code because my questions were finally answered. And then when I did get stuck, the questions I was asking to my peer on the FPGA team were significantly better. He was able to help me more because I had done a lot more basic research. I had poked around in his domain, and now I understood a lot of the basics. So instead of wasting his time with easy questions, now I can actually ask him stuff that he's gonna have to answer for me. And he's gonna be a lot happier because I don't need to spam him with as much nonsense. The point of this story is download other teams' code, take a look at it, especially if you're working on something that crosses team boundaries. Obviously, talk to your peers, have good relationships with them, and get information out of them because a lot of times they'll be very, very helpful. But don't be afraid of just downloading their code, running it, seeing what's going on, looking at the recent changes, combing through the recent commit messages, whatever you need to do to get a base understanding. People will really appreciate it if when you ask them questions, it's clear you've done a lot of research. And poking around in other people's code will make this possible. And not only that, if you at some point want to build something a little more ambitious that's going to cross team lines, if you're able to understand not only your own team's code base at a deep level, but another team's code base at a deep enough level, you are able to actually lead that project now because you have the perspective of both sides and you're gonna be able to bridge that gap between the teams. Cannot recommend this enough. Download other people's code, poke around. Do not ask permission to do this, just jump right in. That's it for the video for today. If you guys are looking for a list of books you can read in the meantime to improve your skills, take a look at this video I posted the other day about 4 must-read books for junior developers. Thanks again for watching the video. We appreciate your support as always. Would love if you guys could drop a like below. It really, really helps the channel. Thank you very much.